Hello, I'm Yaroslav from Lightnovo Customer Support, and this is the follow-up video about Lightnovo LNMR SDK, which allows to control our instruments such as Lightnovo Mini Raman spectrometer and build optimized and customized workflows. In our previous videos, we covered LNMR SDK in Python on Windows, Python in Linux, C in Linux, and C in Windows. And in this video, I will show how to combine all these tools to optimize your workflow and architecture to meet your needs. So basically, I'm running Windows on my laptop now, and what I have here, I have Linux installed under WSL, Windows Subsystem for Linux. And now I'm in my working directory, which is actually, if you check here, is OneDrive folder. And we see the same files here. And as I will be doing some operations and getting some output, logging data and plotting the graphs, they would also immediately appear in the Windows folder, as well as would be synchronized to OneDrive. So LNMR SDK is installed under this instance of Ubuntu under WSL. And so as you can see, what we have here in this folder, we have some Python scripts, some C code, and as well as shell scripts. What is important over here are shell scripts, because we have everything wrapped in bash to optimize our workflow. And our workflow would be to check the system, to check the compatibility of the environment, dependencies of packages, to check the connection, perform the handshake, then to compile C program and run C programs. There are actually two programs. If you check our previous videos on C, logger.c and plot3d.c. Logger.c is actually performing the measurements, data collection, logging everything to CSV file, and at the same time streaming the data to an external app, GreenPlot. After that, after the program is done, another program is launched by the shell script, which is plot3d, and this program would eventually make a 3D plot of time scan and display it on the computer screen in the window, as well as save the PNG file in the folder. So let's check what we have, the workflow, what we have in the bash files. vi editor check.sh. So what we have here, so it's hash bin bash as usual, and we check on the environment in which we are working. We verify the installation and dependencies of packages, and we run basic Python script from our example called hello world, which is connecting to the instrument, performing the handshake basically, and retrieving basic information such as firmware version and the serial number of the device, and so on. So next step is compile. Compile, and actually over here it's just two lines, basically 2 lines of code if we don't consider text output, and we compile logger, linking our libraries, and then we compile plot3d. And plot3d is just a helper which does not include LNMR library provided by Lightnovo. So we quit this. And the last step is the execution of the programs, run.sh. And over here, we run the logger. And the logger, I limited the number of scans to 100. We also will time the program to check the performance, whether it's real time or not. It will give the output, the time, the execution of the execution time of the program. Then what we do, we get the name of the latest logged file, because the program run can be executed multiple times, and you basically, while performing the time scans, then you collect a bunch of data files, and which are automatically saved in the folder. And some output messages, and basically all done. And after logger, we do plot3d. This is plot3d. Latest file CSV, latest CSV file is plotted by plot3d. Cool. So what I have here, this mini Raman, and I have a Lightnovo polystyrene reference sample attached to it. So we'll measure polystyrene. And over here, I have another interesting sample, which is this nice rock with some yellow substance on it. And as you will see, this is actually elemental sulfur. So let's start, and we'll start with checking the system. Check, and you see some text output, and I'll quickly go through it. So basically, I'm, as it shows here, I'm in Ubuntu environment, Ubuntu 24.04. Then what it says, OS Linux, and as you can see, running under WSL. Architecture, x86-64, Python version 3.12.3. Checking if Python version is compatible with LNMR, it gives OK. Checking dependencies, which is basically NumPy, and checking if our Lightnovo LNMR module is installed, and analyzing everything, providing the summary. Test passed. After that, running Hello World application from Lightnovo, showing the device port, model of the device MR, standing for mini Raman, the serial number, firmware version, connection time, 5 milliseconds. So extremely fast. It's extremely fast, taking into account that in the script the port is not hard-coded, and the script is performing a search over all available ports. Then it closes the devices, cleans up, and exits. Done. Next step is to compile the C programs. Compile.sh, run, compiling logger, compiling plot3d, done, build complete. Okay, so now we can proceed with the measurements. Run.sh, we run, and over here I have the window. As you can see, nice polystyrene inspection with a typical peak at around 1000 wave numbers. And let's collect some data. And as you can see over here, it's logging the data to CSV file, which appeared in the folder as well. So scan 51, 52, and let's probably measure sulfur now. So I'm measuring sulfur, and we see typical peaks at low frequencies. What's actually interesting about sulfur is that in old times, sulfur was considered element of fire by alchemists and was actively used in their experiments. And nowadays, sulfur is an ASTM reference standard for low frequency Raman calibration. Okay, and we're done. Then execution time 1 minute, and taking into account the exposure was 300 milliseconds, and we have additional delays in the program, as well as the program is performing live graphical output, as you saw, and logging the data to CSV file. This is pretty good and almost and very efficient, almost real-time performance. Then the script launched the plot3d. Over here we have another GNU plot window, And what you can see here is that in the beginning we had polystyrene sample, 1000 peak, and then in the end of the scan we had these peaks at around 500 from sulfur. So basically, what tells what we can do, as you can see here, timescan with timestamp.png file appeared in the Windows folder, and we can, for example, copy it and paste in Word for our report. Then you can save the file. And so basically, in this video, I think I demonstrated how you can use the combination of different tools, Windows, Linux, Python, and C for your customized workflows. And you can use, you can basically utilize the advantages of each of these tools. The power and efficiency of Linux, convenience of Windows, rapid development time in Python, and very efficient execution of programs written in C, like real-time performance, as you saw it. And with this, I would like to conclude, and thank you for your attention.